asynchronous type of environment in layer 3, and then you're up in layer 4 with the traditional business transaction processing. So MIMOSA, I guess, is playing 2 or 3 roles. We're sort of the sponsor, and we're managing this open pilot. And so the pilot's out completely open on our website, opt-in registration, many people now participating and looking at the activity. We provide part of the portfolio of standards, the MIMOSA piece, as part of the Open O&M initiative. And then we're also helping to manage the working group in ISO that helps assimilate this and provide a practical way of executing everything that we're talking about in a supplier-neutral way. And so we've got multiple owner-operators, multiple EPCs, and multiple suppliers. So,
over there.
Yes, hi, my name's Roberto Michel. I'm with E&P Magazine. And Cliff, I took it from your presentation that the information service bus approach was used in that pilot project. I wanted to know if that's also the approach that will be used with your project in Canada with the NWR refinery. Are you taking that? And
Yeah.
also, do you think that's an easier approach for a greenfield environment than it is for a brownfield?
Absolutely. The answer to your first question is yes, absolutely. We have bought the IIC. MIMOSA actually wrote the standards wrapper that went around it and can go around any enterprise service bus so that you can put data into it in standard format and get it out the other end in standard format. So any software program that has an adapter that talks to standard can talk to any other standard application that has an adapter that talks to standard. And that's the challenge to the suppliers. The second part of your question was, remind me. Yes, for a greenfield, absolutely. You will need an enterprise service bus down the road. There's no question that that's the way the technology is going. No one vendor can integrate all the applications themselves. You're going to have you're going to pick best of breed applications to do the functions that they're designed for, but you need those applications to talk to each other. You need to be able to access data from one to the other. And this design and this approach then decouples that so that if I take down an application that's got an Oracle database underneath it because Oracle's coming along with an upgrade, then I don't break every interface that accesses that application. I only take down one application, everything else keeps running. So the enterprise service bus model is absolutely appropriate for a greenfield and should be retrofitted into brownfields, in my humble opinion.
One quick comment so that we don't offend anybody. So that ISBM spec was actually co-developed with ISA and MIMOSA, OPC Foundation, and we also had people from IBM, Microsoft, and SAP actually take turns hosting the meetings when the spec was being developed. So, what it basically is a bus neutrality API that any of the major, can be added to any major ESB so that when we're doing systems of systems, we're not locked into something that's proprietary to any particular ESB technology.
Yep. ISBM stands for Integrated Service Bus Model or Information Service Bus Model, one of those two.
Are there other questions? Go ahead, please.
I'm Ranga Seshadri from Husky Energy, Calgary. My question is about when we talk about asset information system, how do you maintain the asset being properly kept in ERP as well as control systems and other systems? Because, in ERP we call it as flock, and control system has something, then every individual system that we have. See, how do we go and start designing if it's a greenfield? And if it's a brownfield, then how do you try to have them? Because that, I think, is the one key that we need to use to connect all of them. So what's the practical aspects of that?
I'll bet you Keith would like to take that one.
Sure, I can give you my perspective on that. And I think the way that we're approaching that is around...
Because it's something that's come up a lot in my work over the many years is sometimes when people ask the question you asked, at least the way I heard it, they're really almost talking about asset naming or tag numbering and things like that, because there's a big difference that I've seen in the past construction people don't call the asset the same thing as the maintenance people. It's been a historical issue. And I've done consulting with companies, and the big issue is just trying to and it's not easy to reconcile because one of them group things together, that's a tag number. Another one breaks it into pieces. Sometimes it's a hierarchy, you can break it down, but not otherwise. Is that part of your question as well? Or?
That's a part, and also what happens is when you go to operations, they don't call this as K101. They will say, there's orange guy or a big devil or something like that, right? And another point is also when we go to different systems, the asset hierarchy granularity, that's also important. So to what level we dig into the granularity in terms of looking at assets, right?
The register.
So
Yeah, the first part to your question is, in our case, is that registry. That registry has a global identifier, a universal identifier. Every number and every datum in the whole universe that it's connected to has a unique ID. So it doesn't matter what construction calls it, what operations calls it, what maintenance calls it, that number is that number no matter where it's used. You can give aliases to it to get it by different names. Second part of the question, probably you can address, Alan.
So yeah, actually this was again discussed in the Chevron presentation. Very detailed system of record indexing tied back to the register. And so to Cliff's point, if you start out with an immutable, non-human meaningful GUID, okay, or identifier that's bound to each elemental item that you're dealing with, yes, operations may decide that they've got a tagging nomenclature that they want to use this year for that functional physical location and a P&ID. Each asset that's installed in there over time by the maintenance department may have its own unique identifier, which at different times the maintenance department will decide to change the human readable tag that's associated with that. So these registers really become this common core, and think of it as the index of indexes. And this is something that MIMOSA spent years on in brownfield environments because we're a bunch of old integrators that kept coming together, and every time we ran a project, we'd have to do the same thing over and over again. And we finally decided why not actually just create a standardized model for it, which means you could then build commercial off-the-shelf software for it rather than hacking these things out on every project. So it's this very detailed, very flexible indexing system that allows you to relate everything to everything.
Right, and I'll add one more thing to that, and that is when you do a project, you need something called a tag and document registry so that tags can be identified and farmed out to the different EPCs who are building the plant, and nobody uses the same tags and nobody uses the same documents, and you prevent the overlap and you manage all the names. Then the system knows all that stuff by its unique IDs. Bentley probably does much of that. When they generate their engineering outputs back to us or back to the EPCs, they have to have tags and document numbers all the time.
Can you comment on that, Max? Or?
I'm not technical, but I'll tell you that yes, in fact, one of the major evolutions of the data warehouse family or the asset information family is a tag register system. So we're offering that up now to our customers to use so they don't have to develop their own. So it's very much a part of the solution.
Interesting enough, up until now, or recently, all us owner-operators that needed one had to program our own. Every company that I know of until recently had to do their own software development to develop their own tag and doc registry, usually for every darn project they did.
Keith, just a question, just follow up on that. How do you manage that on a global basis? I mean, you must have to deal with that I have a question, so if nobody else does, but somebody has a question. I want to give the audience a chance. Please, can someone give them the microphone?
Hi, I'm Fred Proctor from NIST, and I want to follow up on this whole the problem which we think of as the nice thing about standards is there's so many to choose from, and it seems to me like you have that problem all over the place, where you have different published specifications that define certain pieces of information in slightly different ways, and you've got to make sense of that. And so one way you do that is you come up with harmonization documents that describes what this term means in terms of other standards, and that's useful. It's just difficult to do, and often those documents don't get published, so they become cultural documents that you keep in-house, and so that all the work you does doesn't benefit other people. And I guess what I'm looking for is, are there any sort of research problems that would make this easier to do? And are you working with universities or computer science folks to try to make it easier when you undertake this harmonization effort to make that easier to do?
Yeah, you've got a good point. The wonderful thing is we've got standards, and standards are a wonderful thing. The other wonderful thing is we got so many of them. The thing that attracted us to the Open O&M initiative, frankly, was that for the first time, you had 5 standards bodies covering the space that we're interested in. We're not interested in, a lot of other maybe spaces that but really plant operations and maintenance and manufacturing factory floor that converged the 5 major standards and collaborated them and stitched them together so that they don't overlap and they fill in the gaps. That's the idea. Is it perfect? No. But it's a hell of a lot better than we've ever had before.
Now, did that result in changes to each of those 5 standards to make them more compatible, or did that result in a 6th thing that tied them all together?
Well, the whole idea of Open O&M was not to create any new standards. It was to harmonize the existing standards. And Alan, you can probably talk to that better than I can.
What we said is, let's take the industry standards groups that already had critical mass pieces of the puzzle, and then let's work together to figure out where the gaps were. And some of the gaps would just be filled by the natural evolution then of those standards as they continued to go forward, and then a couple of them were picked up by things like the ISBM spec that we worked on together, okay, that covered the white space, if you will, that we were driving out through requirements. The other thing is we're working closely with Mark Palmer at NIST, actually already on a series of joint projects which do tie back to this OGI pilot, so that we're sort of building, improving the piece parts, and we do have multiple academic groups and researchers also working with us at the ISO level and at the OGI pilot level. So, love to talk with you more about the collaboration.
Yeah, I would too. I mean,
yeah.
I see this problem in all sorts of different areas: discrete parts manufacturing, assembly, and the issue comes up is you need to harmonize documents. My experience is people do that, and it ends up either on somebody's desktop on their hard drive as the master harmonization document, and you got to call the guy up and get his software in order to do it. And if we can get to the point where those specs are published,
yes,
and it's easy to generate them, that's really going to be
So 2 things. The pilot is being run off our website, opt-in registration only required. You don't have to be a member. Every artifact, every document is published, fully available to everybody in the world. And then once we do the associated ISO technical specification, of course, all those documents will be available through the official ISO mechanism. And that's essentially trailing the pilot, and we're going to document what we prove to work in the pilot rather than just throw wet paper towels at the wall.
And then just a comment on that. I mean, from Chevron's perspective, we're involved, as I found out today, with
The Bechtel iRing team is part of the OGI pilot now.
Yep.
So we've tried to stop the infighting. That's what we've honestly tried to do. I'm not going to tell you it's utopia. People will continue to have disagreements. And amongst adults, that's always true, and it's actually not always a bad thing, because that's how you work out better solutions for the future.
Constructive tension.
Okay, let me ask a question that came up in the presentation, and it's something I'm kind of biased to begin with, I guess, with this. Whenever I had my presentation, I talked about kind of the engineering kind of asset information management versus the operational asset information management. When Keith gave his presentation, he talked about managing what I would have called engineering information. I understand it's used for operation. I've got to be clear. When I say engineering, I don't necessarily mean projects. I mean information about the physical assets, drawings and things like that, more than instrument lists. Drawings of the piping, drawings of the building, drawings of the mechanical structures, drawings of all of that type of stuff, which is generally not used in actual operations. I mean, it's used where it comes back in is it's used when you go to modify the plant. When you're trying to change a structure, you need to know where the beam is and what it's made of and things like that. So it's kind of that technical information. It's used to build the plant and hand it over. And you manage that in a data warehouse, which I don't want to bias that, but that's what I see a lot. When Cliff was up, Cliff made a point. He said, well, Chevron has chosen to centralize the data and put it in a data warehouse where he's choosing to get the data from the systems, which is more of an integration issue. Chevron has a challenge of, once you get that data, extracting some things that are used and passing them down and connecting. I think that Northwest Redwater, the issue is more focusing on the information that's used in operations, in maintenance, like work orders, measurements, just not measurements. When I say that, that's the other thing. I don't mean to confuse and say real-time data. That's part of it, but it's all the other information that's there, but it's more this transactional. I'll call it transactional information in the sense that a work order is a transaction. You know, you create something to drive a process, you do it, and then it saves that it was something that was done. It doesn't change the asset, except that a maintenance was performed on the asset. So I want to make sure that, to me, that what I've said, I'm trying to ask here, I'm sorry for taking so hard to ask this. These guys I know, some we've talked many years.
Sid, that get
but
back.
It's trying to understand and separate those two challenges, because my question really is, the information bus issues and things like that, seems to me it's very important for the operational data. Indeed, you need a way to integrate with applications from the engineering down, where the engineering data warehouse to me sounds like a good answer for that. And actually, you probably, Cliff, when you said I connect to the sources, you mean you connect to his engineering data warehouse. Am I characterizing that right for the audience?
If there's an engineering data warehouse delivered to me, okay? If I have a Spark plant engineering system, they have an engineering data warehouse in there. The point I made and the point I have to have is that it has to be searchable. A lot of the things you mentioned, Sid, are going to go into archives, systems of record, when they get handed over in the plant. At the first turnaround, yeah, we're going to make some changes to that plant, and we're going to have to drag some of that stuff out of the archival systems of record. We have to be able to find it and find it quickly. That's why you need it to be searchable. Case point, every engineer spends an hour and a half to a shift and a half to a day and a half trying to find the doggone stuff, it really slows you down, costs you a lot of money. So the point is it must be computer searchable. If I can go on Google and I can put in a keyword string and I can find a research paper on anything in the world almost that any university has done, why can't I find that document in my voluminous archive files? It has to be searchable.
And it also, I'm sorry for getting into the discussion, but I would also add it has to be related.
Yeah,
so
definitely.
When you get to that one document that's a maintenance document and it says you need these parts, you need to be able to link and say, do I have the parts? What parts are that's a very big issue, which I think you're focusing on managing.
So things like PFDs and P&IDs provide a common context that flows through the entire life, okay, of the plant or platform. And so we directly leverage those atomic elements in a register, okay, which then provides this master index to systems of record which keep changing. And so then you've got topological and schematic type information that gets buried in there. That does point to drawings as well, which may contain structural steel and stuff that we don't really care that much about in the O&M world. Then you got parametric data, and then you got event data. And so if we do it the right way, yes, kind of all the pieces do fit together and can be managed. And I don't think it's an either or. I think it's kind of a continuum.
That's the point I was, just so you know, that was the thing I was belaboring.
You got to be careful that you don't boil the ocean too, because what we're going to focus on to begin with are the process flow diagrams, the P&ID, the process and instrument diagrams, making sure we can provision the downstream systems off of those. And we're going to focus on the equipment parameters and the asset parameters. And that's really the stuff, the critical stuff we need to start up that plant.
That's what you need to start it. That's not what you need to build it.
And that's right.
You need that,
Yep.
but you need a lot of other stuff to build it.